Hello friends, सबको नमस्ते. So today we will create a object detection model on a custom dataset. The dataset which we have is a pothole dataset. So let me explain you some things related to object detection. So let me first define the definition of object detection. Object detection is to find and recognize object in images or videos. It's not only identify what objects are present, but also shows their exit location using boxes. What this definition tells, that means that suppose there is an image of the pothole, so it will first localize the location of that pothole, and then classify that particular object, or we can say localization. That particular localization belongs to the pothole. Means localization classification. So let me explain you. Let me know the three important parts of the object detection. Is first is object localization. Identify what object is. Second is object localization. Means means you can see a location of an object in an image. Okay. Then third thing is a multiple object detection. Means that there is a chances that particular image contain more than one pothole. So multiple localization and multiple classification is there. So multiple object detection tasks has to be performed. Here are some examples. You can say this is a, you can say this a multiple localization and classification, single classification localization. So this way object detection particularly work. So let me explain you what is the working of the object detection. So this is an image, original image you can say, without pre-processing. Okay. Then first localization take place. Means localization where is the potholes in the image. Then classifications. When we combine this all three images in one, we will get this type of image, object detection. Pothole means classification with localization. Okay, so here are some examples of the models is fast RCN and SSD and YOLO. The model which we use in our custom dataset on our custom dataset is SSD. Okay, so let's get started. So this is a directory where is the two files. This is a dataset and this is a Jupyter file of a model which I will explain you. So let me show you the dataset. This is two folder in test. There is only the images of potholes, and this is a train directory which contain two parts: images of the potholes, and number of images which we have is 985, and this is are the labels of them. Let me show you the, so this way you can say this is our details of the bounding boxes. This is the classification. Okay, you can say this is a classification class index, you can say. These are the coordinates values. Okay, so let me open this Jupyter file. This is Jupyter file in Google Colab. Okay, so let me open it, and this is our so let me explain one line by line. Let's get started. So first, create a zip file of your data set. Put that upload, or you can say upload your zip file in a Google Drive and copy this link after sharing, and make sure this thing is ticked, and even with the link, copy the link and just paste it here and capped this part only. Remove all this till slash, and from this remove all this. Okay, you can see that this is a, you can say this is a unique ID of your dataset. Let me erase it. Okay, so the package which we are using here is gdown. Okay, let me run it. It first connect with that GPU, then it will run. So you can say this is a unique ID of your Google Drive, which is uploaded in a Google Drive. Zip file, which is uploaded in a Google Drive. This is a file name. Let me run it. It will first download the, you can say upload the, what is the error? Please check connection and permission. Okay, let me, I think so there is a problem in the link, unique ID. Let me remove this and cap this part. and remove all this. Now run it. See, it's downloading. Let me refresh it. See, the zip file of your dataset. Now we have to unzip it. So we are using this zip file packaging, or you can say library, which for unzipping. Let me refresh it. See, this is a dataset with two folder train and test. Okay. Now these are the libraries which we use for creating a model. Okay. Uh, you can say the for the classification head means we have to replace the classification head. For the head which we are using is SSD classification head, and utils I will tell you what is the meaning of why we are using here utils. See, the weights which we are using is SSD 300 BGG 16 weights. Okay. Now let me explain you this part because this is the important part. So let me first open one annotation file. So there is might be a true problem in annotation file. First thing is that it might be possible that 26 annotation file is there, but image is not the image is not present in an images folder. So that type of annotation file we have to delete it because during training time it's throw an error. And second problem is that there is a possibility that only two coordinates is there and remaining coordinates is not there. It means length of particular this whole thing, this length you can see this the length of this list, or you can see this array is about 5, but here length is 3, means uh, proper coordinates is not there, and those annotation we have to delete those annotation file where the annotation detail is not properly given. So that's the there's a two problem we have to solve before training. Okay, for that I am using here first to remove the annotation file whose image is not there. I am using this lines, and second this line is that for removing the annotation file where the annotation details is not properly given. Okay, so this is you can say these are the directories name which has annotation directory and image directory. Okay, first I have to iterate over the each annotation directory and image directories. It will list all the annotation file name, and here it will list all the image file name. And why I'm using here set, because to increase the preprocessing, if we do not use set, it will work, there is no problem. Okay, now see why only I am iterating over this annotations only, because whole thing means training, pre-processing, everything has to perform on annotation only, because annotation file name it's itself the image name, so all thing has to be performed on the annotation only. That's why I am iterating over the annotations. And first thing I have to get the annotation file path. For that, annotation directory, and this annotation basically contain the file name. After that I have to just use this because full file path name contain .txt at the end. So -4 means only the file name will be there without any extension, and I have to replace that .txt with a jpg. This way I'll get the image file name. I suppose image file name is not present in images. Here images, I already told you what fetch all the image file name. After that, if means if the image file name is not present in image list, we have to remove those annotation file, because during training time it will throw an error that particular image directory is not present. So to avoid those errors, we have to remove those annotation files. And second thing, we have to if suppose annotation file is there and image file both is present. Now second problem is that particular annotation file have to contain proper annotation details, otherwise it will throw an error. So to get that, see, we have to open that annotation file in a reading mode as f. Line.f basically give me details line by line. After getting the you can say detail, I have to len.strip.split basically split that particular line and make it that line into a list. If suppose after getting the data in a list format, we directly get the length. If the length is less than 55, means annotation details is not properly given. We will close that file and remove that annotation file. This way will treat second problem, or we can say solve the second problem if suppose annotation file proper details is not properly given. Okay, now why I'm using here break? Because if one line first line of the rendition file is properly given, it means other details is also properly given. Okay, so let me run it. See, 985 and 985, it means there is no such annotation files where details is not properly given, and also all the annotation file and image file is present. Now let me, this is the custom data sets. You can say a class which will help in which has the data loader to load the data set and create the data loaders. So the variables which is required is image directory, annotations, annotation directory, transformer if any preprocessing is required. Okay, so these are the initialization of the variables. Basically this folder length self dot annotation give me the annotation, you can say length of the annotation, or we can say length of the particular number of images which is present. Okay, here get item self idx annotation. See, you can say the idx act, you can say act as an index value of that annotation file present in a present in this annotation list. Okay, this way we will get the fetch the annotation file name without sorry, with extension. Now we want image path. For that, from annotation only we will get the image path. Just replace the .txt with a jpg. Okay, this way we will get the image path. We have to open that image. If suppose image is not there, we will throw an error. Okay, now you can already know that OpenCP basically read the file in BGR format. So we have to replace that with RGB. So we have to convert that channel by using this CBT color. You can see our function. Now we have to fetch the height and width of the image. This way we will fetch. Why I am fetching this, I will tell you later. Okay. Now this way I get the annotation file name. Okay, these are the list. You can say I will, this is the empty list which we in which we will append the boxes annotation details and the labels. Let me tell you one thing. See, see here, this values is in a normalized format, not in the, see, this 1 2 is not there. This is a displaying. We have our details started from 0 only. Okay, so this values from here till here, this is the normalized values. We have to unnormalize them. For that only, I am fetching this width and height width and height of the image. Now we have to open this another file in reading format. I have to basically get all the details present in that particular file. Line from getting the you can say getting the details line by line. We have to iterate over it. So we have to first get the line, and after line we have to split that and strip that line dot strip dot split basically give me the line detail in the list format. And this list format, you can say this way. See, now here this 5 item, it is in a list format data, but here see, if I am this here line values is in a string format. So to convert that we have to use this strip dot split. Okay, now we can easily fetch the details, because first you can say first string is of class index, then x center, y center, box width and box height. These are the coordinates values which is given in the light line. You can say particular annotation file. We have to unnormalize them. For that, we have to x center divided by width, y center divided by height, box width and height. Now to get the x min and y min value, or x max and y max value, let me explain you what is this x min and y min. X min and y min, you can say the top. You can say top left corner of the bounding box, and y max and x max basically a bottom right corner coordinates. Now how we can get the tails? It is easy to easy to learn, or you can say easy to explain. So for getting the x min value, first we have to x minus box width divided by 2. This way we will divide height with divide with uh, in two parts equally, and we will subtract that to pixels value with x center. This way we will move towards the left side from the center. Now to move above from the center, we have to divide height with divide by 2 and just minus, because for the bicenter you can see the y coordinates from the in the images start from the zero point 0.0 from the top left corner. From in simple line, for the y coordinate 0 0 start from the top left corner of the bounding box. So to move above in a image, we have to subtract this height. Okay. Now X max is the bottom right corner, so we have to move towards the right side. For to move toward the right side, we have to add the work speed divided by 2. Same way for the Bimax, to move down in the images, we have to divide height by 2 and just add it. This way we will get the boxes, bounding box values and the labels. Just append them into the just append them into the you can say into this list, empty list which we have created. See what I am here using int, just just class index will be in an int format, that's why. But why I am adding this class index plus one? Because we are using coco dataset, ssd coco dataset, and in coco dataset, zero index value is already fixed for the background. So to replace that zero index value with a one, I am just adding this plus one in it. Okay. Now we have to convert that in a PyTorch in a tensor format, because we are using a PyTorch framework, and PyTorch all the things has to be in a tensor. That's why. Now, if suppose there is any transformation or in any pre-processing is there in on images, just to add that, and then we have to return this target and images. And here target, you can say, is a dictionary which contain two keys boxes, which is bounding boxes values and labels of each bounding box. So now let me explain you how you can create a model. Before that, let me explain you one thing, that we are using SSD 300, which is 16 weight Coco V1, and in Coco V1 we have 91 classes, 81, 88, 89, 90, 91, and zero index is already fixed for the background. That's why on creating the class for the data loader, I use plus one in a class index. So this is, you can say, this is a architecture of the SSD model. See here, each convolutional, you can say not convolutional, each sequential layer is connected to the head part of the SSD model. This part, this sequential layer, this sequential layer, this sequential layer, and this sequential layers is connected to the head part. So let me open this in a VS Code so that I will explain you more clearly. See this. See here, what is a you see explanation. SSD model is a version of SSD with a bg60 backbone and printed on a Coco dataset. Now this is a model which I have printed. What is in channel? In channel, which is utils. I will tell you that on important libraries we will use that util package. So here it's we are using to you can say to fetch the, or you can say retrieve the out channel of each sequential last layer. Mind my birds, please. Each retrieve the out channels of each sequential last layer. Let me show you one thing. See here, this is a model and this is a in channel 512, 1024 and 256 and 256. Why we are calling it as a in channel? See this. Uh, this layer is connected to the head, okay, and when we have to connect it to the head, we want the out channel of the last layer of these sequentials layer. So that's why we are calling them in a in channel, because we use that out channel as an in channel in our head part. Now where it's 512 come, let me show you. See, this is our first sequential layer and it's AND hit here. So what is the output or output channel of that is 512. So that's why it's coming 512. Now this is, you can say this is a last, not last, second sequential layer. And what is this last layer? This one. And what is its output channel? 1024. And here 1024 act as an in channel. Now this is a third sequential. Last layer 256 as an output. Oh, sorry, 512. Whoa, we're at missed 1024. Oh, sorry, this I missed 512 as an out channel of this sequential. Now for this sequential 256 as an out channel, for this 256 as an out channel, 256 256 512 1024. This way each sequential last layer, you can say, is connected to the head. Now why we are calling it in channel? Because for connection we want the out channel of this last layers. Okay, now see, this is a head. We fetch the in channel using the in channels. Okay, after fetching the in channels, we want now in channels, you can say in channel, we will act, we will use them as an in channel in a head part. Say this head part start from here till here. Okay, now see what is the use, how it's coming 364 546 546, how it's coming. Let me explain you. Now let me explain what is the use of anchor boxes, why I am used here anchor boxes. Okay, number of anchor boxes, model dot anchor boxes number anchor per location, means at a particular location how many number of anchor boxes has to be generated. What is the use of anchor boxes? Anchor boxes used to you can say to detect the objects in the sequential layers. Okay, anchor boxes at different aspect ratio and scales. This line retrieve the number of anchor generated by the model. See this. Let me show you one example of that, so that you will get a. So I will not explain this whole code because this I already made it for visualization. See this. Anchor boxes visualization. Suppose here how many anchor boxes generated? One, two, three, four anchor boxes generated at one location. So this way we have to retrieve that how many number of anchor boxes has to be generated at per location. That's why we use this line, number of anchor boxes per location. Why we have to retrieve this? Because because using this only we can get the output channel value at the classification head. Okay, first line, we fetch the in channel for the head part. Now we want to know what is the out channel. For that part we have to know how, what is the anchor value per location. This line will fetch that. So this is the output of that, 466644. Okay, means first layer we will get, will have four anchor boxes per location. According to that, how this value is getting. See this. Here comment is not working. See here how it's getting 364. According to the anchor boxes, first layer will contain four anchor boxes per location. It means how many number of classes we have? 91. 364. This way we get multiply the how many number of anchor how many classes we have, multiply that with by 4, means how not 4 4 what's the value of 4? 4 here is number of anchor boxes per location. Okay, this list will tell us. Now second layer 364 come for the this second layer is 546. How it's coming? See this 91 multiplied by 6, 546. Same way, 546, 364, 364 value out channel has defined. This way we are using these two lines to get to get the out channel of the sequential of the last layers. After fetching that, fetch number of anchor boxes of the anchor boxes at per location. Using this two only, we will create the classification head and create our head according to our number of classes. See, here number of classes is 91 because before pre-processing on the model, I explain you. After pre-processing on a model, according to our number of classes, how our model looks. See, after pre-processing, our model looks like this. Our classification head changes according to our C output channel. Now let me explain you. See, this is not. What want to explain? See, first layer contain four. First layer contain four anchor boxes. Okay, so four anchor boxes multiply by two. We will get 2. Why we are multiplied by 2? Because after pre-processing on a model, we are using two number of classes. First is a background and second is a pothole. So we have two number of classes. That's why we are multiplying by 8. Now for the second layer, we have 6 number of anchor boxes per location. 6 into 2, we will get 12. Why we are multiplying by 12? I would explain you. Number of classes which we have is 12 here. Same way, now how why here it is 16 here? Because number of anchor boxes is 4. Now uh, number of anchor boxes we have is a 4. See, here is this is a classification head. Okay, this is a regression head which will give me the details of the bounding box. Okay, now how it's 16 came, let me explain you. Multiply 4 multiply by 4. Now first 4, this first 4 basically represent me number of anchor boxes at that at that layer, and I already told you from where we are getting this anchor boxes values. Now see, for the second layer we have 16 number 6 anchor boxes per location. So when we multiply with this by 6 into 4, we will get 24. Now why we are multiplying it with 4? Because 4 coordinates value we will get 4 bounding, because bounding box has only 4 values. That's why we multiply with the 4. Okay, so I hope I explained you clearly what is this classification and regression and how these values are calculated. Okay, so let me open this in the Google Colab. So let me explain you again. This is a function which we use for creating a model according to our number of classes and size. First, we have to retrieve the model with the weights, means pretend model we want. This is in channel, retrieve the out channel of the sequential of the last layer. After fetching the end channel, we want number of anchor boxes per location. Okay. After that, we have to replace the classification head according to our head. So we are using this SSD classification head and passing the inch and number of anchors and classes. You can say this is a adjust the transmitter size to match the input size. This is you can say read this line, you will get more clear picture of that. It's not that tough part for explanation. Okay, after that we will return the model. Okay, uh, this main will not come. Okay, let me erase it. This is enough. Model, create model. After model number classes, which we have two, and we want 640 as a image size. And we have only two classes, pothole and background. After pre-processing, let me run this cell. After pre-processing on a model, replace the classification and according to our number classes. 8, 12, before that the values are different. Okay, so now we have to create a detail loaders. This is a directory of our images and labels. Now this is annotation, train annotation means containing annotation file names. We have to create a train data set. This is, you can say that this is a object of a class. Initialization, we have to pass this parameters, image directories, annotation directories. Transformation means just for the transformation, just we have to convert that things image in a tensor format. Now we have to use this package data loader. Just pass a train dataset in the object. Batch size is 4. Shuffle means shuffling is there. Call, and this thing create a data loader for us. Okay, batch size. Now let me run it. Let me run this way. 247 is the length of the train data loader, which give me the detail that 247 batches is there, and each batch contain 4 images. Now we have to uh, set the learning rate optimizer. See here, device means here this line give me detail that which device which we are using. Okay, so device which we are using have to be safe, because all the things, the model, images, labels, bounding box has to be on the same device. So this way we will make model on a CPU or in a GPU according to this line. Okay, this parameter mm, p dot require gets. Let me one more thing I want to see. What's see this here? P dot required grid. What is the meaning of this? After iterating over model dot parameters, it will first see p dot require grade means parameters require grade variable, or it's not variable, attribute value. If it is true, what is the meaning of this? True means this that particular weight will change during training. If it is false, during training, though that weight will not change, this remain constant, okay, say fixed. It will, okay, say this particular line, this line from here to here, it will create the list of all the parameters which is trainable, which is updatable, which is has to be changed during training. After this, we have to pass this params list into this optimizer. The optimizer which we are using is SGD. Learning rate, initial learning rate value is 0.01, momentum is 0.9. Now we are using a scheduler. What is the use of the scheduler? Scheduler, first thing, it will avoid overfitting, and means mostly it is used for overfitting only. There are other reasons also, but mostly it is used for the overfitting only, to avoid the overfitting. And see, its value has to be 0.01. For I already hit and tried many times, but 0.01 is the best one. Now running scheduler means it will change the value at per you can say per interval of a particular interval of time. The interval of time which we are using is step size as 3. It means after every third epoch it will change the learning rate value after it multiply with the 0.1 value. So for example, if the initial learning rate value is 0.01, so after third epoch, it will multiply with 0.1, and its value will get changed from 0.01 to 0.001. Means now this is, you can see this is the first epoch, this is the second epoch, this is the third epoch. After third epoch, again it's multiplied with 0.01. This way, learning scheduler work. It's changed the value of learning rate after every interval time. Though The interval time which we are using is step size 3. Let me run it the cell. Now we have to check the data loader that bounding box details is particularly mapping the correct image or not. So figure means you can say fig will present the entire image. You can say axis for iterating over the subplots. We are just representing the two images. One row, two column means two images. Figure size built in by 6. Here x is in 2D format. Now here x is in a 1D format just for the ease of iteration. First we have to create the iterator. Now x next, and by using the next it will give me two variables, images and target, and each here images basically contain four images and targets containing you can see the annotation values and the labels values of four images. Okay, class name bg, I already told you the zero index values for the bg and the one index values for the pothole. Now we have to iterate over it. First, what is the use of permute here? See, when we use transform to tensor, it's basically convert the image shape into CHW. But here I am so required HWC, HWC shape of the image. So to convert CH to shape of the image to HWC, we are using permute here. Okay, now fetching the first details, labels and annotation, bounding box details. We have to use this. We have to details according to the index values. After fetching the index values, you already know this target is basically the index, not index, dictionary, which contain two keys, boxes and labels. To fetch the details of that, we use this way we will fetch the details. Just fetching retrievals, it is possible that there might be more than two bounding boxes, or there might be more than two potholes in the image. So we have to iterate over it. After iterating over it, x min, y min, I will tell you what is the meaning of that. Just fetch, and how this way, you can say this way we will get the width and height of the image. X min just minus x max, y x min, y max, y min. After that, just create the patch of the patch of the bounding box using this patches or rectangle. See, patches x min, y min. You can say the initial coordinates. You can say top left coordinates, and just pass the height and width of the image. Let's create the patch of the rectangle. After patching we have to add this patch in a you can say in a subplot, and this way we will create the text on a image. We can say not on a image, on a bounding box. Let me run it. See, it's getting the images. Pothole means it's correctly defining, means our data loader is correctly mapping the labels, or you can say bounding box with the correct image. Now training part is started. So number of epochs which we are using is you can say 10. That print the statements that training started. Modular train, I tell you that modular train just to make sure that the model is in a training mode, and during training mode weights values is updated. If model is in evaluation mode, weights value will not change. Train learning loss initially is zero, but we use this for you can say getting the losses values at each epoch, not at each epoch, at each batch. Now just we have to iterate over the train data loader. It will give me the images and targets of I feel I will talk about the first iteration. It will give me the values of four values, not values, information of all four images, labels and annotation details. Okay, now this two line basically used for make sure that models and the device, models, images and targets is on the same device. Now just pass the images and targets. This line basically return the directory of the loss, which contain two things, uh, two items. I will explain you these things, because in SSD we have only two two detection two detection head. See, see. in head part, we have only two things: classification head and regression head. So in SSD, we have only two type of loss: classification loss and regression loss only. Okay, so we have to add those losses, okay, to get the complete loss. According to that loss only, optimizer zero grade will work. It will calculate the gradient values. Okay, now this is important to note that optimizer zero grade has to be there at each uh, sorry, one mistake is there. Optimizer zero grade will not calculate as gradient value, but it will convert the gradient value to zero. Why we have to convert the gradient value to zero at each iteration of batch? Because if we do not use this, the gradient value of previous batch will get accumulate to the current batch iteration, and it disturb the weights value, or you can say the weights value will not update it properly. So to avoid this type of errors, during training this will not throw an error, but ultimately it will disturb your model training part. It will throw you can say model will not get proper accuracy. That's why. Now losses dot backward, basically here the computation take parts, means all the weights value computed here and gradient value computed here. One more thing, that losses dot backward, here come only computation part takes, not the updation take parts. Now optimizer dot step, basically here the updation of the weights take parts. Now training learning losses dot item, after fetching the losses, adding the losses of two losses classification and regression had, we have to add this and we have to fetch this training learning loss. Now this way we will get after, if I will continuously iteration take place, at first epoch we get all the losses of all the images. Okay, in train learning loss it will add all the losses of all the images. Before that, let me explain you what is in, or how the losses dot dict look like, and after adding this, how it's look like. Let me run it. See, I already told you that loss.dict basically contain two type of loss only: bounding box regression loss and a classification loss. After adding this two thing, 246.508, this way after losses.dict, this here, this losses basically after adding we will get this value. Okay, so this way SSD basically contain only two type of loss: classification load and regression load. After adding that, we will get the complete loss and we will cap this in this way. After whole batch iteration, we use the step scheduler step to, after every interval of time, interval of epoch, we will change the learning rate value. Now we have to append this in a train loss. Now just uh, print the train loss. What is the loss of our model? Just multiply with divided by the train data set 0.4 0.4. You all know what is the meaning of that, because after point we want only four values. So let me run it. Now our training cat started. After that we will save that. This is not a faster CNN. This is SSD custom. SSD custom. Okay. Now here we are saving the model. Now after that we have to test the model, that how our model is performing on our unseen images. Okay, so this line, I already told you what is the meaning of this line. This will tell us that what device we are using, either whether we are using CPU or a GPU. Now create model, basically give in return it give me the model. I already explained you this function create model above in a code. Just pass the number of classes and size. This will return the model. After returning, it will return the model. We have to load the weights. which we save after training. Now here we are not training the model. We are evaluating the model. We do not want any updation of weights, so that's why we are using modular eval. Don't confuse that task data loader. We are not using that. Just I have write this line for the explanation. Okay, so don't get confused. I already explained to these two lines. Transformations. One more thing, that all the pre-processing which you have done on the images had to be done on the test images. Otherwise, it will throw an error. The transformation of the pre-processing we have done just to convert that image in a two tensor format. Okay, this way images is a folder. Not here images. Here should be this thing, pothole test images. Okay, now this line is extra, so let me erase it. Here test list slide basically give me all the images name from this directory. Now this is the class names. Now we have to iterate over it. Range 1 because I think so we are just plotting to two images. Let me increase the values here. I want to plot 4 by 4 means 16 images. 4 means 4 rows, 4 columns. Now this line will give me the image path from the test directory. Random choice, I will tell you randomly choose the test image file name, randomly choice. Now we have to open this, apply the pre-processing. And squeeze 0, I will tell you it will add the batch dimension. Means dimension now will be get like this, V C H W. This is the dimension of the image after unsqueeze 02. Otherwise here the dimension is before using the unsqueeze, here dimension is use CHW, because after using a two tensor it will get this dimension CHW. Okay, and squeeze basically just add one dimension in it. And two device, I already told you what's the meaning of two device. It will make sure that image tensor has to be on the same device with where the model is. Now torch dot no grade means there is no updation, just pass the images. To fetch the detail of first image we are using a zero index, because we are just passing one image at a time, so we will get zero index means fetching only the prediction of the first image. Just print that prediction. After printing that, here just to I already told you that I am show uh, plot or I am show required HWC format, not CHW format. So to you convert that, we are using permute here. Now to fetch the predictions details, because prediction you can say it is a dictionary which contains scores, labels, and boxes. Has a key. So to fetch these details, we have to use this type of line: prediction boxes cpu.numpy. Okay. After fetching this, plot the images, access is off, or open the image. These are the, you can say these are the bounding boxes colors. Boxes, I will tell you that now we have to iterate over this all these three, because we have to represent score also, labels also, and boxes also. To iterate at the same time iterating over this line, iterate over them, we have to use the zip here. Just color dot color 0. Not here color will be like random color has to be choice, random choice colors. It may here it will randomly select the color. Now if score is greater than 0.8, what is the meaning of that? Means I only display the those bounding boxes whose score is greater than 80%. I want to display those bounding boxes on an image only. So after that we have to use this box. It will give me this detail x min y min. This line till here is already explained you above using data loader test. Okay, this line is extra. So this way our work is done. So let me complete this training part. I think so it's already completed 10. So let me run this cell also. It will save the model. Let me run this. See, these are the predictions. Here it's not detected this pothole. Here is the detections. Now you will get, you can say, not satisfied with the model, not performing very well. Okay, somewhere it's performing very well, but somewhere it's not performing very well. So don't get worried. You can see that at epoch 10, its accuracy, its loss is 0.48. Okay, but suppose if you increase the epoch's value till 50 or more than 50, you will see the result will drastically change. It will detect more clearly. Okay, more clearly it will detect. So I already had a model which is trained on a 50 epoch. So let me upload that model and show the result of that model. Okay, so so wait for a while. So friends, this is weights which is trained on 50 epochs. So let me show you the difference between the weights values which is trained on 10 epoch and 50 epochs. So let me run this cell. See, see the result. See the result. See the it's easy to say the difference when the epoch is when the model is trained on 10 epoch and the model is trained on 50 epoch. So this way we can increase the accuracy. So let me show you the how the predictions of one image look like. So let's assume that this is a prediction from here till here. This is a prediction of last image. So you can see this is a tensor. You can say this is a key bounding boxes values, and this is a say this is a score of each bounding box, and this is a label of each bounding box. You can see the bounding box score start from 1 and it's reached till 0.3, 0. Different bounding box have different score. What we are but here we are displaying only the bounding box whose score is greater than 0.8. Okay, so this way you can control the bounding box representation, and uh, either if you want to increase the accuracy more, you can increase the epoch. Okay, this way you can increase the accuracy. So this is a model, you can download it and use it wherever you want. Okay, so please, friends, if you want more videos like this where I will explain you deep of the model so that you solve your confusion, your confusion get clear. So please share, subscribe, comment my video. Please, just motivate me to make more videos like this where I will explain you more models with deeper knowledge. Okay, please share, subscribe, comment. Thanks to all.